This is The Art of Startup War, and I am your sensei, Brian McMahon. Now, in Season 1 and 2, I got inside the minds of startup investors. In Season 3, I brought in entrepreneurs to share their startup journey. Here, in Season 4, we combine both, so you can hear investors critique the investment value proposition of individual companies. You're going to hear how investors make decisions to invest in startups, what makes a great entrepreneur, and how billion-dollar companies are built. So tune in every Tuesday, 10 a.m. on all the major platforms. You can empower your tribe by sharing the podcast, and remember to subscribe, rate, review, and leave us a comment. Good morning, it's Brian, it's Expert Dojo again. You are here at The Art of Startup War, and we are talking to a phenomenal entrepreneur who is going to tell us all about his company and how he's got started. Now, here's the thing with Allan. A lot of the time, you will hear me say, oh, we're great friends, this is really good, we've been in the dojo for ages, but not the case with me and Allan, right? This is the first time we've had a chat about this. However, Alex Kisson, who's our fund manager, said to me at least 5 times, this guy Allan is awesome. His business is awesome. It's going to have huge impact in the world. You have to see him. It's going to make a massive difference. And actually, we should invest in the guy. So I love this because I don't know any more than that. But when I hear that from Alex, it means it's something pretty special. So welcome to the show.
Thanks, Brian. Excited to be here.
So we're going to talk all about you, which is my favorite subject, is not talking about me. So tell me a little bit about MSB. Tell me how the company started. I want to know it all.
Sure, absolutely. Well, I'm originally from Toronto, Canada, and went to
Of course
school
you
up
are, because
there.
you're a nice guy. You see, I knew that as soon as you walk in. You're like, really nice. I said to you, the first thing I said, we're late for the podcast. I'm like, Allan, mate, I'm so sorry. We're like fucking miles late. He's going, it's okay. He's not from here.
Oh, man. I meet nice people everywhere I go, though. Yeah, so I went to school up there, and then I was focusing on aerospace and high-performance computing and computational science, and I started finding opportunities in the United States after grad school, and I moved down here. I've been here ever since, and so I've worked in energy.
You came straight to California?
I came straight to the West Coast, but I started in Arizona, then went to Washington State for a little bit, and then I've been here now like over 5 years.
Wow,
Yeah.
okay, cool. And then what got you into startup? I mean, you were probably kind of in startup from the time you were in grad school.
It's true.
I'm guessing, right? Because you're in there and you're going, dang, I think I just invented something.
You're right, but also I'll tell you, I had a few experiences that got me on the track to focus on being in small companies. My first job out of grad school was working for this enterprise engineering software company, and at the time, their particular focus was aviation, and they were selling software to the tier 1 aerospace companies, and particularly the engine manufacturers. And actually, this is a really wacky story because I came right from grad school into this company. Company's called New Mecca. This was right before 9/11, and commercial aviation was just slaughtered after 9/11. I mean, everybody was hit really hard. Everybody was canceling their orders, and that affected this company. And so, even though actually I was brought into the company to focus on be the head of the technical stuff, like the consulting and the support and everything like that, the company's plans changed in a number of ways, and leadership in the U.S. operations changed, and so they put me in charge of their U.S. operations very soon after departing grad school and coming into the company. And so,
Wow.
so this was a pretty small company, not exactly a startup, but a very small company, and it was like a crash course in running a small company and learning all about what it takes to sell enterprise software, and also a crash course in what it's like in all these tier 1 companies. And I love these companies. I work very closely with them, and I love being a consultant to them, and I love to work very hard for them. But something that I decided very early on was when I was going around and visiting all these companies was that I didn't want to be an employee at one because something very different between a large company like that and a small company is you go into these large companies and they have massive rooms full of cubicles, and then you go to each one of the cubicles, and they're all working on very cool stuff, but it's a little bit bleak.
Mm.
In the
No, it's way more than a little bit bleak.
in these
It's
in these
horrible.
environments.
It's horrible. Like if somebody said to you, "Here's what's going to happen: you're going to get born, and you're going to come out into light, and you're going to be surrounded by love and affection and attention. It's going to be absolutely glorious. And then in the beginning part of your life, you're going to learn how to like enjoy and have fun and really be prepared for the future. And then for the next 50 years." You're going to sit at a desk doing something that somebody tells you to do every single day. And if you do what you're told properly, you can come back the next day. You're like, dude, I don't know. Like the first bit sounded really good, but then the last bit sounds really shitty. Well, like every single, and that's what I look. And so we work. Some people don't have a choice, right? So I say it respectfully on some levels because you got to bring up families and you got to do stuff. But it's a fucking miserable existence, and you don't get any opportunity to explore the beautiful creative side that makes us us, right?
Yeah, I totally agree with you. And one of the things that amazes me is there are some people that I've worked very closely with at a number of these kinds of large companies who are in exactly this situation, but they found the way to make a difference anyway.
That's
And
true. That's a good point. Okay, so there's an outlier, right? That's true.
and
Very true, right?
so it's
They
it's
find
it's
they
like
find purpose, right? They find purpose and meaning within a greater organism that can make a bigger difference. It's true.
it's always amazing to me when I witness this because you know, these companies should really. I think. I mean, some of these companies, I think, do try to institute different structures inside to make it possible for people to break out and try different things and rotate around the company and um, pursue kind of like new innovative things, and so they're not just stuck in, designing the latest revision of a design they've ultimately been working on for 10 years. Um, but it's amazing to me when I see people in these organizations that somehow have found a way to make a difference and they're really recognized for it. But there are so many other people in these companies who have amazing capabilities that kind of get worn down, and eventually they realize the way that they're going to be able to ascend in this organization is to become part of management, and then
Mm.
they get on that track instead. And anyway, so I was witnessing this, for the first time, really firsthand, when I was in my early 20s, when I was in this situation, and I thought, okay, I am going to focus on small companies, and that's what I've done ever since.
Uh-huh.
And I guess the size of company that I've gone to has shrunk ever since as well, because I started in a company that was mm, you know, 30 to 50 people.
Yeah.
And then I went to a company after that in Washington State called Ramgen Power Systems that
Mm.
was about 20, 30 people. And then after that, I went to a company called Maston Space Systems, which was, well, depending on the period of time and what project we were working on, between 10 and 30 people.
Yeah.
And then our startup is quite new, and it's just a handful of people.
Yeah.
But you know, there's just this radical difference in what you're able to pursue, the way decisions are made, also what the goals of the organization are, and what the what holds back certain things. I mean, something that I commonly say to a lot of people is there are a lot of like large companies that cannot afford to innovate.
Yeah.
And the reason is, like, if you have quarterly profits,
No, it's the innovator's dilemma. They get stuck with it. So then how did you fast forward to where you are now?
I, I've been extraordinarily lucky, personally, throughout the course of my work to have access to some extraordinary high performance computing facilities. And one of them is the Department of Energy's Oak Ridge Leadership Computing Facility.
Mm.
And throughout my work, I've worked in aviation, energy, like green energy kind of applications, and also space launch as well. And uh, in each of those organizations, I was working on very aggressive technology development programs, things like aircraft engine technology. We were in Washington State at Ramgen, we were developing this experimental high-speed turbo machinery
Mm.
that was enabling a compressor to do like a 100 to 1 pressure ratio in like a single stage, where usually it's like 2 to 1 or like maybe 10 to 1 if you're lucky. So it was like a radical improvement, and like some of the technology that we're working on really looked like alien technology.
Yeah.
It's kind of like we're working with high speed aerodynamics. So if you're familiar with the famous hypersonic space spy plane that's called the SR-71. It's kind
Yeah.
of like mixing the SR-71 with like a fan, and like what that would look if they were somehow mated together. And then also at Masten Space Systems, we were working on a DARPA program to build
So you're dealing with some highly technical and complicated stuff. So, but I want to get to the point of when you suddenly had a moment
Mhm.
of,
Yeah.
this is my new company.
Yep.
This is what it's going to look like.
Yeah. So I saw I saw a massive unmet need, and so the reason I wanted to talk about the supercomputing stuff. Long story short, in several projects, we applied the power of high performance computing to design challenges, and it enabled us to explore concepts and evolve concepts, like brand new concepts, into working prototypes before we ever built anything, several times. And it made a radical difference in each of these companies' ability to innovate, and what they ended up delivering. And I realized from the many companies that I had worked with when I was on the vendor side, and then the companies that I had been working at and consulting for when I was on the engineer side. And I realized, when you bring in this capability into a company, it makes a radical difference in what they're able to do. But there are so many barriers involved that result in most of these companies not doing it.
Yeah.
And there's this like crazy statistic that came out in this recent market research report that 92% of product development and manufacturing companies in the United States are not using high performance computing in engineering. And okay, so that's like a lot of complicated words. So let's break down what that means. If you're designing something brand new, like let's say you're Wile E. Coyote, and you want to design some brand new rocket skates because you got to catch that Roadrunner.
Mm-hmm.
Well, okay, you don't just grab a bunch of rockets and tape it to some skates, and you're ready to go. Like, if you're not careful, you're going to create so much heat. When you put on those skates, you're going to melt your feet off. So you're going to have to do some thermal analysis, make sure you design those skates, just so. And also, these skates are going to vibrate. If you're not careful, you want to do a little
Mm-hmm.
vibration analysis, make sure that you get that right so you don't shake your feet off.
Yeah.
And then, of course, you want to go fast. That's the whole point of these rocket skates. So you want to
Yeah.
do some aerodynamic analysis too. Now, those are three specialist disciplines in engineering out of like 1,000 or more, where there's like specialized software that has been developed for each individual application. And if you're a pro, like from the 8% of the companies that are using this stuff, like the aircraft companies out there, for example, um, then you're going to have this radical advantage, because you're going to be able to try like 1,000 or 10,000 different designs, as
Yeah.
opposed to if you're like the 92%, like everybody
So
else.
this is a question of scale. When you talk about
Oh
supercomputing
man,
power, it's a question of capacity and scale.
yeah.
So most companies, so I want to keep this on a level where most people understand what we're talking about,
Hmm.
and because most of us think, well, man, if you got a computer, why don't you just get a bigger computer? And the truth is, you,
Right.
you can't just
You
get a
got to
bigger
know how to
computer,
use it.
right? Exactly. It's not about, well, why don't you use more data? Well, yeah, the data all exists out there. It's not about using more data. It's about being able to compile and compress and then decimate the data or dissimulate the data in a
Yeah.
way that people will understand it. So I hear what you're saying.
Hmm.
And what I'm trying to understand
Hmm.
is to make a computer into a supercomputer where it can fully do all of the things that it needs to do. And you mentioned airlines, which
Hmm.
is obviously a reference from airlines 30, 40 years ago, where they were like same for ages. And then they suddenly turned into like super airlines, and now they're totally different. And they're
Yeah.
like, because they just crack the code. Now, is cracking that code, is it a technology or is it a service? Because I'm wondering, like, is it 10 of the greatest, like if we're talking chess here, is this like four grandmasters that need to work this out, or is it a chess algorithm that just helps play better chess?
Yeah, right. Yeah, so the aircraft example is a great example. In the 50s, 60s, 70s, 80s, 90s, like the plane that you would fly across the pond back and forth didn't look very different between like over several decades. And the reason is because that thing needs to be safe. You don't want to try too many different things from one design to the next. And then every time you try something new, you got to build a prototype, put it in the wind tunnel. Then you got to build a larger prototype and fly it for real. And that's really expensive and time consuming. The difference now is that all these aviation companies are using supercomputers to iterate their designs in virtual prototypes. And these days, something that's brand new, like when I started using supercomputers, you couldn't rent cloud time. Uh,
Aren't cars doing the same thing?
yes. So some are,
Car manufacturers, huh?
that's right. Like airplane manufacturers are an example of like companies that like really started doing that first, and then other industries have started to catch up. There are so many that haven't, and the primary reason why they haven't is because it's hard. It takes a lot of expertise to use all this specialized software like thermal analysis, vibration analysis, aerodynamic analysis. All that specialized software takes, a couple years of training each. And if you want to use like 1,000 different expert discipline pieces of software, if you're like most companies that have fewer than 100 employees, you're never going to be able to use all those tools. You'll use like a couple of them. And then it takes expertise to actually use the cloud computing to run it at scale. And so what's missing is this missing expertise. And so I saw this need over and over and over again. And lately, more people have been actually reporting the need. So the industry, HPC industry has reported it. NASA has been reporting it. Department of Energy is reporting it. Everybody's screaming, okay, actually, like one of the reasons they think that like American manufacturing is behind and is not competitive is because even though America is a world leader in supercomputing, we're actually not using it here very much.
But how do you turn it into? So my question
Yeah.
before, is it a technology?
Hmm.
Is it an API, a technology, a software, or is it smart? Is it a smart people business? Because if it's a smart people business that you have, it's a great business, but it's a service business.
Yeah. So
But if
so
it's a,
so what it is it's a little bit of a combination of everything, but at its core it's an artificial intelligence driven assistant. And we've come up with a way to build in that expertise that you need to be able to use that kind of specialized software and to deploy it for your design problem on these cloud systems. And so the big idea here is so-called expertise as a service. How do you take, specialized steps that you would go through to run specialized software to do that thermal analysis, vibration analysis, and aerodynamic analysis, for example, and make the decisions that you need to make to apply it to, the end user's specific design problem, and then how would you deploy those jobs to cloud and then get back useful information for the designer. So because we have been doing that ourselves for a while now using the top government supercomputing facilities like Oak Ridge, for
Mhm.
example. Um, we did it a number of times, and we realized after a while that, okay, we kind of have figured out what does work and what doesn't work, and we could take this a few steps further and come up with an assistant that not only enables us to automate and build intelligence into our own engineering workflows, but actually be easy enough so that these end users that don't have that kind of computational science experience or high performance computing experience, they would be able to use those tools and that cloud infrastructure
But
as well.
so how would it work though? So I'm a medium-sized company, like 100, people. We're doing something relatively technical. Do I just go off the shelf? Do I go onto your website and I just pay like $5,000 a month, and $5,000 a month gets me access to this artificial intelligence, or do I need you to come out and actually do a consultancy?
Yeah, so it's very much so it's a SaaS model. So it's you have a subscription and then there's a pay as you go part to it. So and actually you can do it all as pay as you go if you want. So if you
Hmm.
don't want to, buy the annual subscription up front, you just want to try it by pay as you go, you can do that. But I tell people it's kind of like Amazon Prime in that with Amazon Prime, you pay for a subscription, and then you also register your credit card or your account details so you can do one-click purchasing
Hmm.
when Amazon Prime has curated products, to recommend to you that you can just easily purchase those products. With our assistant that we call Guru, you pay for the annual license, or you just use it as pay as you go if you don't want to commit to the license. And then when you ask Guru to run the thermal analysis job, for example, Guru will automatically select what third-party engineering software it's going to invoke for that job based on your requests and what kind of information is asked from you. And then it'll also choose the cloud computing system it's going to deploy that job to. And then it's going to take your credits that you have purchased and spend those on those third party services to run that end-to-end workflow.
Okay. Okay, so and so what's the traction like so far? How long have you been running the company? What kind of revenue is it bringing in? How are you fully deployed? Is the software built?
So we're early stage. We're pre-revenue. Except for we have some consulting revenue that we've done because we've
Huh?
been working with some companies that we've done some proof of concept with. But we have letters of interest from several customers that want to be our first commercial customers, and we have the working prototypes. We're building the commercial platform to deploy to those first customers right now. So it's kind of like Dropbox at the beginning was one guy. Drew Houston made the
Yeah.
first version of Dropbox that worked on his laptop, connected to his computer at home, and enabled him to grab his files. But in order for him to have something that he could sell to other people, he needed commercial servers that were secure,
Of
and he
course,
needed
yeah.
the application working on multiple operating systems. And so he sought enough investment to enable him, to build the first version of the commercial platform, and that enabled him to bring a co-founder and small team of developers and go on and become a $10 billion company. And so we're at the stage we have working prototypes. We have companies that want it. We have vendors that want to be on the system, and we're right now pushing to get the first commercial version out.
Okay, and then what's the journey been like so far? So has it? It doesn't seem too painful. It doesn't have to be painful, but it seems like you've built it in a relatively smart and painless way. Is that fair or no?
Well, I'm so glad to hear you say that because that it means I'm doing a really good job of
I'm looking
masking
calm.
a lot of the difficulty involved. But no, it's been tough. Like it's certainly been a huge benefit to us that we started this journey not with some brand new idea of a product that we wanted to invent for the first time and then go after it and then start having to figure out everything about it. Like it was really an organic process where we were engineers ourselves working on very high stakes technology development programs, and we were very lucky to have access to premier supercomputing time. And the crazy thing is that over like a course of like a 10-year period, where at the beginning of that 10-year period, people that would be using high performance computing would either have to buy their own cluster or they would have to apply to the government to try to get supercomputing time. It went from that situation, which obviously there are some natural barriers to a lot of people getting into that, to a situation where everybody now can rent time on AWS, IBM Cloud,
Sure.
Google Cloud, Microsoft Azure, and but what's missing it's missing a layer on top of that that would make it easy for this so-called missing middle of the market. And so we began working on for other companies, working on other technology development programs,
Yeah.
and we figured out what works and what doesn't. And we got to a certain point where we realized, okay, yeah, we could take this a few steps further and actually develop a system that would enable non-experts to be able to do this too. And then at the exact same time that we were doing that, the cloud computing infrastructure was all built out, and it was like kind of like this beautiful thing that's ready for us now. And then there's this other situation that because I was working for an enterprise engineering software company, I had intimate knowledge of. There are all these different specialized software companies that have like 100 customers worldwide. uh, Now some of them will have more like hundreds, and like the really big ones, the ones that you've heard the most about, might have like single digit thousands. But just in the United States, there are like more than 250,000 product development and manufacturing companies. And when you talk to any of these specialized engineering software vendors, why do you have like 1/100th the sales that you could have? um, Everybody says two things, and it doesn't matter if there's like the tiny one or the biggest one. They all say the exact same thing. The software is too hard to use and it's too expensive. And so they have these long sales cycles, these really high cost of customer acquisition sales cycles. And so they're only ever selling to this minuscule fraction of who they should be. And so there's this massive opportunity that's sitting there of this cloud infrastructure that's underused.
No, I get it. And you're gonna build it and put it together and make everything more streamlined. But where can this go to? Like, if you're gonna say it in a very non-technical
Hmm.
way for investors and folks who
Yeah.
are trying to see like what do the milestones look like going forward? Do you need $1 million? You need $50 million? You need $500 million? And what does that do? Like, how much is going to come in for the companies? Just paint us a picture of kind of what the future looks
Sure,
like.
yeah. For as far as fundraising goes, so we are raising $2 million as a total seed raise right now,
Mm-hmm.
and we have about a 2-year technology roadmap that we are basing that raise on. The most critical part of that roadmap right now is our initial commercial customer launch,
Mm-hmm.
and so we're trying to close 500K to make sure that we get that done ASAP. And But what it looks like over the roadmap is, right now we're at phase one where we're doing the commercial launch, and have very intentionally selected a relatively small number of first customers to go to. And the reason is that we want to do what people like Paul Graham recommend of Paul Graham famously talks about doing things that don't scale. He talks about the importance of when you have your first customer engagement, work very closely with them and make sure that they're thrilled, and make
I like
sure.
that a lot. That by the way, I think that that mentality is not spoken about enough. Like too many people are way too quick to try and get massive users at the beginning, and what they do is they build on a faulty foundation.
Yeah, that's right. And if you're not careful, you could have this false launch that you convince everybody that you suck, and and then
But
and
it's
then
true. But
uh,
then why go for 2 million? Why not go
yeah,
for a smaller amount
sure,
and use that first customer as then the your beta maybe, and
absolutely.
then do next and then next and next.
Yeah. So the key part of the raise is the 500K. we are trying to lock in some developers that we've been working very closely on
Gotcha.
this,
Okay. So
and
it's for you want some you need to start building hardcore team members around you.
that's right.
And I suppose it doesn't matter if it's one customer or 20 customers, those same team members are going to be vital for to having what you need to have built, right?
That's right, because we want to, continue building with these people, and they're going to be key to the way we scale up. That's a big part of it, and also our go-to-market, involves some sales initiatives that are not extraordinarily cheap. Like,
Yeah.
we one of the other nice things of how we came to this is that, for instance, I have experience on the enterprise engineering software vendor side, and so I understand some realities of what it takes to sell in these kinds of markets. And so, part of our sales strategy is, we're going to have a, VP of sales, who has great experience in this area. Now, also, once we get past the first phase where we're iterating and making sure that our first customers are thrilled, the next immediate phase is as we start to grow into a larger customer base, where our first beachheads are aerospace and energy, by the way.
Yeah.
Southern California is a great
No,
place to be
I
for
can
that.
see where it can go to. I suppose I'm looking just for bigger blocks rather than the smaller blocks.
Yeah.
So if we're looking at, so we're saying, okay, great, you get into the first customer, you open that up. Then in 2020, I mean, do you have a feel as to, or 2021, do you have a feel as to, or even 2025, like, do you have a feel as to what kind of revenue can come through for this?
Absolutely. Oh yeah. So no, this scales up relatively quickly. We're talking about, in about 3 years getting to 100 million, and we have a detailed map of how we get there. The first phase is very slow and very small, because we want to make sure that we are developing something that the first customers agree they love and they will actually want to start vouching for. But um, the next stage is taking the third-party vendors, as part of our sales channel. Now, these engineering software vendors that I was telling you about that are selling to like 1/100th of the companies they could be if their
Mm-hmm.
software was not so complicated. Um, a lot of them really like the idea that we are going to have a solution to enable them to
For sure.
bring in more customers, and they like the idea that. The solution that we're building, it does not compete with the business that they already have, because if you are already a customer of these kinds of companies, you've gone through the training and
No, they're going to be
everything.
happy. Listen, no, so like it's a no brainer. They're
So
going
it's
to
a
like,
sales channel.
yeah, they're going to like what you do, and they're going to see it, and it's going to be good. But where do you see what I'm trying to do is paint a picture for your potential investors here of what the company looks like going forward. So are we? I think everybody gets the idea of the value, and they get the idea of like supercomputing, and they can see where supercomputing is going. And as more data's out there, and computers cannot keep up as quick, like it makes sense.
Yep.
But if anybody's going to put money in, they want to see like what's going to be coming back,
Yeah,
and
absolutely.
whether it's revenues or whether it's rounds you're going to go through. Just give us a little bit of a feel before we finish.
Yeah, absolutely. So we're talking about, in the first 3 years going through about three different stages of scale up, and we expect, to, by the end of about 3 years, be at an annual revenue of about $100 million from subscriptions. And one of the keys to
It's a
the
lot
way
of
we
money.
yeah. So one of the ways that we get up to that scale is, one of the keys to our intellectual property is, we figured out some important ways to scale up the amount of capabilities that we're able to offer in the assistant. So we have, several adjacent markets, within the global areas of starting with aerospace and energy. There are several different specific markets that we are able to sell to as a consequence of this scale up. And we this is already like a tested market. We know the opportunity that's already there, and we know, why people are not buying at this scale already, and we know what would make the difference for them to come in. Long story short, there has never been a marketplace for engineering software. And the reason is because it's never made sense because it's so complicated to use. It's like theoretically just like not practical, because you can't just go in and choose one piece of software or the other,
No, I
because
get it. It's
the
hard.
conventional way you'd have to take too much training.
It's hard. There's too much going on. I want to make sure. I want to finish it on the revenue, and I want to finish it kind of where you are and everything else. Let's finish up with a email address, website. How can people contact you?
Yeah.
And then maybe just a final quick summary statement on why what you're doing is so incredibly important.
Absolutely. So you can reach me at Allan at msb.ai, and that's just Mike Sierra Bravo Alpha India. So the big idea here is that we are delivering engineering expertise as a service at scale, and that's the really big idea that we figured out. And to give you an example of what kind of difference it makes for these customers, of the 8% that are using high performance computing and engineering today, the companies that use it are reporting that they get a 500 to 1 return on investment. Every dollar they spend on high performance computing and engineering, they get 500 back in increased revenue. And the reason is they have a faster engineering process, they have a cheaper one because they don't have to hire outside contractors as much, and they have a better one because they're able to try like 1,000 different design options as opposed to just a handful. And so it's really a step change in their ability to innovate.
Very cool. I love it. Okay, so you've heard it here. Obviously, anyone who can contact, they know exactly how to contact you. I will be getting out to Alex. It is massively head-growing stuff because it's the edge of the universe and all that kind of stuff. But no question, supercomputing is the center of it all. Alan, it's been a pleasure having you on the show.
Thanks, Brian. It's been a pleasure for me.
It's a wrap. Thanks for joining us. If you love the podcast, please empower your circle by sharing these stories. The Art of Startup War is brought to you by Expert Dojo. And remember, we invest in startups, $50,000 checks. Make sure you apply on our site if you are one of those great entrepreneurs looking to bring your company to the next level. As far as the Art of Startup War is concerned, we are back every single Tuesday at 10 a.m. So remember, check out the new episodes. If you want to find out what the investors think, check out season 1 or 2. But make sure you join us every single week.